hello.com. My name is Wei Siang and my metric number is AF170224. Okay, now I will start present our project summary. Our project is about eight two-story housing construction project, and it is located at Jalan Residency 4, Taman Residency Sri Utama of Jalan Ipoh to Rawang in Kuala Lumpur. And our contract value is approximately at 2.5 million. For our project material properties, for beam, all our beam is 200 times 600 millimeter, and it is concrete, and the slab thickness 125 millimeter. Column is 300 times 300, and the stump height is 1,200 millimeter. Floor height is 3,000 millimeter. Concrete unit weight 25 kilonewton per meter cube, and for the FCK is 24 Newton per millimeter square, and for the FIK is 460 Newton per millimeter square, and for the cover is 35 millimeter. For the loading application and distribution, the loading at GB is, for the dead load is 1.2 kilonewton per meter square, and for the live load is 1.5 kilonewton per meter square, and for the loading at 1B is dead load is 1.2 kilonewton per meter square, live load is 1.5 kilonewton per meter square, and for the loading at RB is, for the dead load is 1.0 kilonewton per meter square, and for the live load is 1.5 kilonewton per meter square. Okay, so for the manual calculation for GB8, okay, so first we have to find for the, because the GB8 is located at the floor slab 1 at the left, so we need to calculate the loading, the GK and QK. Then we find the BVX, like Ly over Lx 1.9, and it is lower than 2, so we have to find the BVX, so we can calculate the GK, and then we get the design load is 27.4 kilonewton per meter, and for the shear force is 56.31, and for the moment is 57.86, and for the main reinforcement we calculate it as we use the 3H12 as it is 339 millimeter square as we calculated. And for the shear reinforcement, first we use the design shear force 56.21 kilonewton, then we calculate it, then we found out that it is below, we are the max, that the theta is equal to 22 degree, so we use degree equal to 22 degree. So for the shearing, we use the H10 as the 300 millimeter, and so for the deflection, and we have found that it is okay for the beam, okay, and for the cracking it also okay, because it is below than the bar spacing is below than the max and the above bar spacing. And that's all for me. Thank you. And now I will pass to my teammates.
Good afternoon, my name is Azim from Deli, metric number AF170018. So today I will present about the manual calculation for Esteem project, and I will show you the manual calculation for the beam. So for our project, so this is the ground beam for our project. This is the ground plan, and for my part is I will calculate the GB7, which is here, GB7 ground beam 7. This is at the, so I will calculate the GB7 here, and we can zoom, and this is GB7 that I want to do a manual calculation. For that I will compare using the Esteem software calculation and the manual calculation, whether it is same or a little bit different. So my beam is, size beam is 200 times 600 mm, and the length of the beam is from here to here is 13.86 meter, and the given FCK is 24.6 mm per square, and the FYK is 460 Newton per millimeter square, and the concrete unit weight is 25 kilometers per meter cube. Okay, so we proceed to the manual calculation. First, we need to do a loading and analysis. As usual, we calculate the beam surface 0.20 times 0.60 times concrete unit weight 25, and we get 2.0 kN per meter, and permanent load you also get 1.2 kN per meter, and the given GK, QK is K 4.2, QK 1.5, and we calculate the design addition using formula WD equals 1.35 GK plus 1.5 QK, and we get the design action is 7.92. Okay, so after that we draw the SFD and the MD diagram, and we find the shear force using the formula V equal to WD L over 2, and we get the shear force is 54.89 kN, and the bending moment is we get 190.18 kN per meter. So this information we need to differentiate between the Esteem software. So we proceed to calculation the main reinforcement. The effective depth is 527.5 mm, and we proceed to the design bending moment. We want to find whether K is larger or less than cable. So K we get 0.142, and for the cable is we get 0.167. So from the calculation you can see that cable is larger than K, so the compression reinforcement is not required for this beam. So we calculate the exact, so that we get 432.6 meter, and then we proceed to the AS, we get 1100 meter square. So we can use the 10 H test, which the area is 1131, so it's larger than 101, so it's okay. So we proceed to the minimum and maximum reinforcement. So for the S is minimum, we get approximate 173 mm square, and for the AS max we get approximate 4800 mm square. So we proceed to the shear reinforcement. So from our equation we get the design shear force is 44.89 kN. So we calculate the area, so we get the angle. So for the deflection we calculate, and we get the percentage is 15.25, so I think this is okay for our design of thing. So this is the manual calculation for my part is GB7. So that's all for me. Thank you.
Good morning, doctor. My name is Chee and my metric number is AF170237. So now I will present about the manual calculation for ground beam 12. So first, before we proceed with our analysis, we need to write down our specification. So this is our specification, which is the effective span L equal to 2.3 meter, and this is the width and the depth of the beam, which is 200 multiplied by 600 millimeter, and so on. For the characteristic strength of the concrete, characteristic strength for the steel reinforcement and cover and concrete unit weight, diameter of link and diameter of bar. So next is the loading. So the loading add on the ground beam 12 is from the slab of FS2 and FS11 and also the brakes. So next, this is the characteristic permanent load. We calculate for the beam self weight and then for the load add from FS2 and FS11 and also from wall. So this is our GK. Next, we proceed with our characteristic variable load. So after calculate this, we need to factor it with 1.35 GK plus 1.5 QK. So this is our W. So next we calculate our bending moment and draw the bending moment diagram and also shear force and shear force diagram. So next is the main reinforcement. So since the K is lower than 0.167, the compression reinforcement is not required. And this is the reinforcement area required, which is 105.59. We use 2H12, which is the reinforcement area provided is equal to 226 mm squared. Next, we calculate the minimum and maximum. So minimum is 164.3, and here the provided area is larger than the minimum area and below the maximum area. So the provided area is okay. After that, we calculate the shear reinforcement. So this is the shear reinforcement. This is the design shear force. After that, we get the shear link. So this is the ratio of shear link area per spacing, which is 0.08. So here is the maximum spacing, and we use H10 500, and this is the minimum links. After that, we also calculate for the deflection. So since the actual span effective depth is lower than the allowable span effective depth ratio, so the deflection is okay. And after that, we calculate for the cracking. So since the bar spacing is below than the maximum allowable bar spacing, so cracking is okay. After that, this is the comparison between Esteem and manual calculation. So the bending moment we can see here. Actually, the difference between manual calculation and Esteem is very little, which the bending moment is around 1 point something for the difference. And after that, the reinforcement area provided is also same, and deflection is also okay. So conclusion. To conclude, Esteem is a convenient and effective designing software to be used in which it helps to reduce a lot of time in calculating and checking the failure of the design. That's all. Thank you, Doctor.